The first one is the fundamental physical quantities. Fundamental physical quantities. So now let's understand the meaning of the fundamental physical quantities. As from the name only we can say that these quantities are very fundamental. So something is very fundamental, it means that is very basic to the quantities. So if I want to learn all other quantities, it means I should know about these quantities, right? So I can say that the fundamental quantities are independent from all of other quantities. This is the first criteria to be called as fundamental quantity, right? So the first thing is these are independent from each other, independent. Second is that from these group of fundamental quantities, all other quantities can be derived. Okay, I will explain it. Just let's write down first. So all other quantities can be derived. So these two statements combined make the definition for the fundamental physical quantity. You can say the fundamental physical quantity is that quantity which is, or are quantities, are those quantities which are independent from all of other quantities, and all the other quantities can be derived from them, right? So you cannot say that like, okay, length is the fundamental, and like only one statement you cannot make. You need to define a group of the quantities, and then you can say that these are the fundamental and the others are the derived. Others will be called as the derived. Okay, so here as we discuss about the unit system, so we will keep 7 quantities as the fundamental quantities. These fundamental quantities are these 7 fundamental quantities are mass, length, time, temperature. So right now you just need to memorize this list. What are the significance of these quantities, how to measure these quantities, what will be the units, all those things we will discuss. About the units in this chapter we will discuss, and the remaining, what are these quantities, how to calculate these quantities, all of those things we will discuss in the coming chapters. So no need to worry about that. Now next, okay, these are the 7 fundamental quantities. Let's discuss the SI units of these fundamental quantities along with this fundamental quantities list. So right here I'm writing down the SI units of these quantities. These are 7 fundamental quantity, and as you know, mass is measured in kilograms. So some SI units are very famous, you must be knowing about them. So first one is mass is measured in kilograms, okay, and it is represented by kg. Length is measured in meters and it is represented by small m. Time is measured in seconds. Temperature is measured in Kelvin. Electric current is measured in amperes. And amount of substance, as you know, is measured in moles. And luminous intensity is measured in cadela. So these are the SI units. Again, we will discuss about these SI units. Right now you need to memorize this list. So these are the fundamental quantity. Now there may be the question in your mind, why we are selecting only these 7 quantities? Who is deciding these 7 quantities? So like, think it like this. I can define the area as fundamental. So I cannot define the length, because you know that the length multiplied by length is the area. So I can calculate the length from the area. So like this, these are the 7 quantities which are independent, and now all other quantities can be derived from it. Like for example, you want to calculate velocity, right? Now velocity is a quantity, and I have not listed that quantity in these 7 quantities. So now what is the velocity? Velocity is the, as you may be knowing that formula of the velocity. Velocity is the displacement divided by time, right? Now what is the displacement? Displacement is kind of length, right? So length is a fundamental quantity, time is a fundamental quantity, right? So I can calculate the velocity. So no need to define separately this velocity as a fundamental quantity if I have defined the displacement and the time as the fundamental quantity. So I think you are able to understand why we are listing these 7 quantities as the fundamental quantities. Now why not the other quantities as the fundamental quantity? If I list other quantities as the fundamental quantity, I can list it, no problem in that. But then I need to remove the other quantities which are dependent on them. Like for example, if there is area, right? If I am listing the area as fundamental, then I cannot list the length as the fundamental quantity. So yeah, now next thing is the derived quantity. Of course, if you have understood this fundamental quantities very well, then you can understand this the concept of the derived quantities as well. So let's move to the derived quantities. So Now think it, what should be the definition of the derived quantities? The derived quantities are the dependent quantities. The quantities which are dependent on the fundamental quantities are basically the derived quantities, right? Yeah. So quantities which are dependent on the fundamental quantities. Yeah, pardon me. Quantities. Okay. So how many of them are the derived quantities? Yeah, there is no such list of the derived quantities. There are n number of the derived quantity. All other quantities which are defined can now be called as the derived quantities, apart from these 7 fundamental quantities. So how many are there? N number of them. There can be any n number of the quantities, right? Okay. So the quantities, just I'm writing down few of those examples. So the examples are the velocity, acceleration. Okay, think of it like area, volume, any other quantity which you can think, force, right? Yes. Power, work, energy, so on and so forth, right? These are the derived quantities. Now, of course, if we are going to change the list of the fundamental quantities, then there will be surely the change in the derived quantity. And there can be a hypothetical question like this in the any competitive exam, where they can change the fundamental quantity and then can ask, now tell me the formula of this quantity in the terms of these quantities. You can derive from the relations, right? Now the units of the derived quantities is called as derived units of the derived quantities, derived units. So this will be a very interesting case. Let's understand some of the examples. How do we derive the units? So here I'm taking very basic example of the velocity. Okay, so now tell me, for derivation of the units, you should know the formula, otherwise you cannot derive. So tell me the velocity formula. Velocity is the displacement divided by time, right? Displacement divided by. Now this formula, in this formula we are going to substitute all those quantities which are still the derived quantities. We are going to substitute the formula of those quantities in the terms of the fundamental quantity. But right now this case is very simple. Here I have taken the velocity. Velocity is a displacement divided by time. Displacement anyway is a fundamental and time is fundamental, so no need to worry. We can directly derive the unit form right here, right? So the velocity is a displacement divided by time. Displacement is a fundamental quantity and the unit of the displacement, SI unit of the displacement is meter and the time is second. So that's why the SI unit of the velocity is meter per second. Will be the SI unit of velocity. Very simple and basic example which you can understand very easily. Meter per second. Now there will not be any need to memorize the unit. Now you can say even if you forget the unit of the velocity, you can think of the formula. Velocity is displacement divided by time. Now you know the displacement is measured in meter and the time is measured in the second, so you can derive the formula unit of the velocity, that will be meter per second, right? So next let's take some more examples to understand. Okay, what will be the formula of the acceleration? Acceleration would be the change in velocity divided by change in time, and change in something and that the quantity both will have the same unit. Like for example, change in the length and the length both will be measured in the meters, right? So tell me the change in the velocity and velocity, what will be the unit for both of them? The meter per second, right? And the time is seconds. So if you want to find out the formula of the acceleration, you should know the formula of the acceleration in the you should know the formula of the velocity or the unit of the velocity, then you can find out the unit of the acceleration. So this will be meter per second divided by second, so that is meter per second square. So SI unit of the acceleration is meter per second square. Okay, so next one I am going to give you as an example question to you to solve. Okay, now can you derive the unit of force? Just try it. What will be the SI unit of the force? Okay, so now tell me the formula of the force. Force is mass multiplied by acceleration according to the Newton's second law. Okay, you might be knowing. If you don't know this formula, anyway we are going to learn these formulas in the Newton's laws of motion, so no need to worry. Still some formulas you can memorize from your 9th 10th class which you have learned, so that it will help in this chapter. So force is mass multiplied by acceleration. Mass, I know this is fundamental, and the unit of the mass is kilogram, and the unit of the acceleration is meter per second square. So unit of the force is kilogram meter per second square. This is SI unit. SI unit of force is kilogram meter per second square. So although we don't use this unit so much because the Newton's laws were formulated, that's why to we replace this unit by the name of Newton, and we represent it with the Newton. So although you can say the unit of the force is kilogram meter per second square, there is nothing wrong in that, but still generally we will be preferring this Newtons. That is the same thing. If I ask you, can you derive the unit of SI unit of volume? So now what is the formula for the volume? If you take different kind of the bodies, the formula might be different. Like for example, if I take a cylinder, the volume is pi r square L. If you take a cube, the formula is side cube. If you take a cuboid, then that is length multiplied by breadth multiplied by height. So there will be the different formula. You can take any of the formula. Let's take the volume of the cylinder. We know that the formula is pi r square h. We know pi is just a constant that will not have any kind of unit, right? R is length and h is also length, and length is measured in the meters. So that's why SI unit of the volume would be meter cube. So anyway, you know, if you are going to take the volume, you are going to multiply the three dimensions of the object: length, breadth and height. So there will be the length will be repeated 3 times, so that's why it will be meter cube. If you take any kind of area, the length will be repeated 2 times, will be multiplied by 2 times. That's why the unit of the area will be meter square. SI unit of the area will be meter square. So I think from this lecture, the idea of the fundamental physical quantities and the derived physical quantities and derived units will be clear. And right after this lecture, you can attempt some